Welcome guys back again to another video. So in this particular video we're going to talk about the transamination in biosynthesis pathways, right? Okay, in our previous videos we have talked about many general reactions which are occurred in biosynthesis pathway like alkylation, SAM methylation, DNTP, likewise. So in this video we're going to talk about the transamination. Okay, first of all, you need to know this particular molecule, right? This is PLP. So let me take which is pyridoxal phosphate. The common structure is given here, right? Mostly like this R group is represented by OP. So this is the common. There's a methyl group here, right? This is a methyl group. This is the common structure of PLP, which you need to know, right? You need to know this. What's the structure of PLP? And when it comes to transamination, this is the reaction which we are focusing on, right? There are two components. One is one containing a carbonyl carbon, which is the CO group, and other one containing an amine group. So what basically happened, like the name suggests, transamination means you can see when the reaction happens here, this NH2 is changing its position with this oxygen. You can see right here. For the NH2 group, now we have a carbonyl part. For the carbonyl part, we have a NH2 part, right? Basically, this transition happened. This is basically the transamination. This is the reaction. So we need two components. First thing is the PLP and the other one is transaminase enzyme. So these are biosynthesis pathways. That's why these reactions are driven by enzymes. Okay. So PLP and transaminase enzymes are the major two components which are driven, which drive these reactions forward to our final product. You need to know the PLP and transaminase. You do not need to know about the structure of transaminase. Just know the name and the mechanism. That's the main important other thing. So we are going to talk about the mechanism of this particular reaction. Okay, here in the first step, this is the PLP. Okay, this is the PLP. Now in the first step you can see imine formation happen. Imine formation. So let me take the yellow color so you can highlight these things. Imine formation. This is the imine formation. I hope you know the imine formation, which is a very basic reaction in organic chemistry. I have explained it in our previous not our previous video, I guess in 2 to 3 previous videos, right? So I will put the link in this right corner. Basically what happens is this, there's a carbonyl, this is a carbonyl compound, right? So oxygen is replaced by this nitrogen here, just like this. For carbonyl compound, there's a carbon and oxygen. Now it's carbon and nitrogen. This is what happens when the imine is formation. I have not put the mechanism for imine formation here because it's not complicated one. But there are some steps. There are some few steps which is going to be longer, which will make this video longer. So I hope many of you will know about the imine formation. If you are not remember or if you not recall the theory of the imine formation, I highly suggest you to go back to that specific video because imine formation is very important. But I want you to know one specific thing. This imine formation happens in now biosynthesis pathway, right? So this is a biosynthesis pathway instead of other chemicals, right? The bases, acids. Now there are enzymes. Okay, so always remember when it comes to the biosynthesis pathway, when it comes to the metabolized reactions, always there are enzymes. There are no reagents like KCl, KMnO4. No, there are no reagents like that. There are enzymes. Enzymes are the one who drive this reaction forward. So first one is the imine formation. So basically this go and attack here and form the carbon nitrogen double bond. In the next step, right, you can see there's a hydrogen over here. For this carbon, there's a hydrogen. This hydrogen will be removed from the base. So this bond is broken and forms a new bond with our nitrogen, which is a pi bond. Now you can see this nitrogen is becoming unstable, so it pushes this pi bond to here. Now this goes here and this one go and find a proton. Now we obtain our next structure, this one. You can see now there's a double bond with nitrogen. There's a carbon, and again double bond here. This double bond is shifted to this place. This double bond here, okay, this double bond is shifted to form a bond with the hydrogen. Okay, now this is our structure. Okay, this is our structure. Now what's happening is, you can see this is an aromatic compound, right? This ring contains aromaticity. This is an aromatic ring, right? But this is not an aromatic ring. I hope you know that the aromatic ring contains additional stability for your molecule. So when this reaction happens, the aromatic ring get disturbed. So this structure is relatively a little bit unstabilized. So in the next step, what happens is, this ring, right, this ring obtains its aromatic character back again to get stabilized. So to obtain that particular aromatic structure, this kind of mechanism happens. So let me draw this. Bond is broken back into our ring, so this getting shifted here. Now this carbon, this pi bond is go and attack to a proton in our environment. Now we can obtain this particular structure. So now there's a hydrogen attached to this carbon. Now here we have our structure. So like, yeah, this is OP, right? This is not a change. So this OP is from the beginning, right? Otherwise you will get confused, right? There's a OP on the beginning. This is the there's a OP. This is oxygen and phosphate group. Oxygen and phosphate group, right? Don't get confused by, right? Sorry, I have done that mistake. So like, this is not a new one, right? This is not a new one. I mean, so this is like this. Okay, there's nothing happened with here, right? It is initially there, right? Don't get confused over that too. Okay, now here we have our structure like this, and then in our final step, what happens is imine hydrolyzation, hydrolysis of imine. So this is again we have talked about in our organic mechanisms. So I think you know the mechanism for hydrolysis of imine. So which gives you two molecules. One is a amine, another one is a carbonyl compound. So I will put the link above to, if you are not remember about the mechanism of hydrolysis of imine, basically the reverse of the formation of imine, right? So if you know the imine formation, then think about the reverse of that particular mechanism. Then there you have a hydrolysis of imine. So if you are in a very specific case, if you are not recalling that, I will put the link here. You can go back and watch that video. Basically like 3 minutes to 4 minutes, both these are. It's not getting that much time, so you can recall it. Both these reactions are very important, right? So in your final step, you can obtain your final product here. This is the carbonyl compound. You can see now there was a NH2 group. Now it has been replaced by a oxygen. So this is basically the transamination mechanism. Okay, this is the transamination mechanism. I hope you got the idea. So this is very important when it comes to the biological systems and biological synthesis. So these kind of like this kind of mechanism, like these kind of steps, you should be memorized. You should memorize, right? It's not a thing to memorize, but just take the idea, right? Just understand the process, understand the stability and unstability, then you can arrange it in your own. So this is not a big deal, right? Not a big deal, right? So I mean, write this mechanism on your own for 5 to 6 times, then you can easily memorize these things. So, and always focus on these specific details, right? The arrow position diagrams, these are very important when it comes to the exams, right? So if you are not clearly mentioned about these arrow pushing diagrams, these arrows, these protons, like you cannot put a hydroxyl groups like this, right? So if some let me take an example like this. If you have a deprotonation, right, like this, if you have a deprotonation, you know, a base should be there to assist the deprotonation, right? So you cannot put a hydroxyl group as a base because these are biological systems. So for biological systems, there are enzymes. Enzymes are the one who act as a weak bases. So you can't put OH minus groups. You can mention easily B and 2 electrons. This is a weak base. So these kind of small points are very important when it comes to biological synthesis. So I hope you get the idea about the transamination. Be very careful when you draw the arrow pushing diagram. Thank you. And if you have any problems, please free to comment below. And if I have done a specific mistake, please be free to point it out.